So it's my second project. In my first project, I have built a conveyor system. In that project, I have learned the entire digital input, digital output, and it's my second project of the PID. So in this project, I have mainly focused on analog input, analog output learning, and PID learning. So let's first of all take the overview of the project. So here is the set value of the PID, and it's a tank. It's fully animated with a value. Here is the PID gain, TP, KI, KD. So we will add it. We will set the set points, and all this is the we have looked at what the process will be going on. So in this thing, there is a tank. Its value will be available 0 to 10. Here is the filling valve and this is the drain valve. So it will be analog type. So value will be 0 to 10 for both of it, and each is the level sensor. Its value will also will be in the 0 to 10 volt. So let's first of all start with the auto mode. So we have set the 50% set value. So in range, it will be 50 because tank is 0 to 300. So it's going on. Derived value of the filling valve will be available from the PID as per our set points. Let's start the error. It's now correcting the errors and it's now oscillating. After some time, it will be stable. And here, entire PID will be programmed by my own self in the SCL logic, not use the PID Compact instruction as for learning purpose. And we can also modify the gain as per our requirement. So we can learn different what is the result of the gain that we will also further look at what is the effect of gain on the PID. So first of all, it's have a alarm, analog type and digital type. So if value will be high, then it will be critical high alarm, then critical, and value will be low, it will be critical low alarm. And if PID is going on and filling valve may be off, so up at the correction will be calculated PID, but actually valve is off. So PID after few seconds will be detected as valve is off. And if the valve is by reason open and not in control mode, so it's in saturation mode, so continuously give the water. In that condition also PID will detect the valve is saturated. So let's step by step we will check all the alarms and work into the PID. So first of all, PID valve off. So let's forcefully I have closed the valve. Now see the valve is forcefully I have closed it. So PID will detect it, the valve will be off and alarm will be generated and buzzer will be off. Listen, filling valve failure detected and in alarm it will be available. Filling valve failure detected, valve will be off. So let's now check the critical low level error as I will forcefully drain. So it's now available level critical low detection at its set at 20%. So it will be not reset until the level will be high. So I forcefully fill the tank, which automatically will be a reset. Now let make another error. The filling valve will be saturated, so it will be 100% on. So after the set value 150, it continuously filling, so it will detect the valve will be saturated by the PID, and alarm will be available as the PID will be off the valve, but in actual valve will be filling because of it is forcefully saturated. So now after few time PID will detect it there is a error. So before the PID will be detect, a critical high error will be detected. So just possible drain force it to minor level and keep in auto mode. So now PID will detect the as a PID have keep the valve off, but its valve is saturated, so it will be rising the value. So PID will detect valve is saturated and alarm will be given. There is a time delay. I have kept is avoid to saturation, not forcefully generate the alarm. So it will be take a time for a few time. It will rise the alarm. So it's available. Alarm is available. We can check it. Filling valve failure detection. Filling valve saturated. So PID is working properly, and is the error because of we have manually keep the error much more high. So I will be integrator. So let's reset it first of all and keep out working. It's a fully animated display and tailored in the three version as the input of the sensor will be about 0 to 10, and our entire PID will take data into percentage. So first of all converted actual value in percentage, and for show at the HMI as a tank is from 0 to 300. Let's look at here. It's a 300 graph. So for it convert 0 to 300 buck and scale also. It will be actually show it here. It's a working of the project. It's fully controlled and detect all alarm and all failures. So let's now go to the project and look what is the code. So first of all, it's a folder structure. So here's the FC library and FBN global DB will be defined. PLC tag will be defined here, and its improper mapping will be done. The main thing is the FBPID, which is written in my own way in the SCL logic. So its input will be taken in the auto, so is auto mode or manual mode. Set front from the HMI, actual feedback from the factory IO sensor, the gain from the HMI, and this is the output. What will be the PID generated? So here is the core logic. First of all, we have defined a P term. P term is the current error into KP gain. I term is the integral error. So I have keep the integral in the state of the FB. So it will be retained at every scan time. And in the next time I will add it the current error. So it will be behave like integral. And for generate it item, put the same I will KD and the current error minus previous error. And finally summation of all will be the process value. Here I have make the range from if a process value greater than 100, so it will be forcefully do the 100 and it will be going in minus, so it will be keep to 0 as a valve will not get the minus value, it will be the problem, and not more than 10 voltage, so it will be the scaling of the process value. Here is the logic for alarm detection. So first of all, filling valve off. So when will be the filling valve off will be done? If the condition will be entirely whitened here. Same for the filling valve saturated alarm logic. It whitened here. And finally write the output to the output of register of the block, and it's write the data for the next 10 cycles, and in else make all the things to 0. And here is the scaling FC which I have written from percentage to actual value to percentage value from FC HMI interface. Here in FC HMI interface, FC I have written the entire logic for the HMI display and animation purpose. Here is the HMI alarm, analog and alarm. So here is I have defined the level, low level and high level error. It's a higher and lower model. Two is at 75% it will be the warning, and 85% it will be the critical error. So it will be stop the system and pop up the alarm. Same for the low level at 25% low level detection warning, and at 20 it will be the alarm. And this is a discrete alarm. So filling valve off and filling valve off and saturation will be programmed here, and fully automation will be animation will be generated in the and center code will be available on the GitHub. I will share the link. So this project is mainly for learning the analog programming, how to handle analog input, how to handle analog output, and properly scale it, and from HMI how to make animation. As in industry, analog scaling is much more required. As here is the I have used the factory IO, so value will be available in 0 to 10 volt. But in actual industry, it will be available in 0 to 27,000 something value in the PLC. So first of all, I require to convert it in the percentage and then process the value, and PID output will be available in again in the percentage. But actual value, the sensor will be required is 0 to 10 or 4 to 20 volts. So we have required much more conversions. So for it, I have used the Normax and Kalex instruction. So here is the percentage to value, and it's actual value to percentage conversion in HMI interface. I have converted for the 0 to 300 tank bar level. So it's a program for is the many much more kind of I have used the norm XLX for the conversions. So it's my project and I have learning the PLC programming. So you can watch my journey and there is a much more upcoming project will be available. So thank you.